Could you go all the way down to friction quiz? 1 and 2, we're going to do those first. And how about you work about 10 minutes and work together? How about that? Work about 10 minutes on your own.
Yes. Yes. When the non-enough location, yes.
How do you get to the 95? Go to the gravity.
You going okay, girls? You want to start doing it together? Okay, we'll do it together. Ready? Okay, as a wooden block slides at constant velocity, whenever you see friction and constant velocity, what's that? The friction force must be equal. So this is something that you memorize. When you're going at constant velocity, A equals 0, so the friction force, the one that goes this way, is equal to the force parallel to the incline. They're equal but opposite. Okay? Just have to memorize that. So at constant, maybe why don't you do a sheet of paper out so you can write some good stuff down. Avoid tips. So at constant B, A equals 0, F net equals 0. There's not a question like that, so don't worry. But at constant B, A equals 0, F net equals 0, and so the opposing forces are equal. At constant B, A equals 0, F net equals 0, so the opposing forces are equal. Do not worry about number 2. Do not worry about number 2. Okay? Definitely not going to get that super hard one, but you could get something like number 3. Wooden crate slides across warehouse floor. If the crate were filled, the coefficient of friction. Write this down. What's the coefficient of friction? Write that down. Coefficient of friction is the roughness number. So now you should know the answer. If you fill the crate, does the roughness of the floor change? Does the roughness of the crate change? Absolutely not. It's a trick question, right? So I'll say it again. Coefficient of friction, roughness number. Now, if they said you put oil, okay, right? Oil on the floor, well, that'll change it. Or you put wax on your skis, that will change it. That's a trick question. Coefficient of friction is the roughness number. What happens to the force of friction? Well, this is a different story. If the crate is filled, doesn't the crate press harder on the ground? And shouldn't the friction go up? That's logical, right? If there's more weight in the crate, the crate presses hard on the ground, But that's just logical, right? You get more friction. So let's take a look. Let's take a look at this one. Ready? So here's what I do on the test. A 5 Newton block. FG. Girls, why is that FG not M? Because it's Newtons, right? Whenever you see Newton, that's FG. Drag across the Regents loves to give you a horizontal table to make it nice and easy. Horizontal table. Everybody write horizontal. F normal equals FG. So you'll see that on my test because I won't kill you. It'll be a horizontal table. I'll give you the typical question. It experiences a force of friction. That's little f. What kind? Well, it's sliding, right? It's not starting. What is the friction force acting on the block when it's increased to 2A? You know what that is? That's a trick question. Why is that a trick question? Did you change the roughness? Did you change the weight? No. It's a trick question. It remains the same. It's still 2 newtons. What are the two things that determine friction like we talked about today? The roughness, did you change it? No. I didn't change the roughness of either object. Did you change the weight? No. So that was a trick question. Well, the Regis likes to, see if you know those two factors like you talked about today. Only the force and the texture, we changed neither. All right, which quantities determine the coefficient of friction for granite on concrete? Well, we just talked about that. Then which two factors determine the coefficient of friction? Do you remember the symbol for coefficient of friction, girls? What's that? That's that Greek letter. What do you call it? Mu. That's it's written like U a lot of times, but it's really a Greek letter. It's mu. Now, go ahead.
About like the previous question, like I don't know how to solve it.
Oh no, this is easy. I think this might even be on the test.
I was wondering about like the one.
Or maybe not. Maybe it's on the midterm. Anyway, so watch what we do. We go. Let me look at my equation sheet. You'll have this. You'll have this as well. Okay. The equation on the reference table tells you what the answer is. What's the coefficient? That's the mu. So what's the answer? Right there in the reference. 8. You get that? All you have to do is look at your reference table because it's telling you the answer. What determines the coefficient? The mu, well, the normal, and the friction. So right there on the table. Oh, this is a good one. Force required to start an object sliding is larger than the force required to keep it sliding. These forces are different because the force of kinetic friction is, what do you think, Kathleen? The force of kinetic is what? What do you think? Good. That's good. So remember that kinetic friction, when you write on our sheet, is always less than starting a static friction. Good job. So that's a basic fact that kinetic friction is less than static. Good thing to memorize. Kind of a popular question. I may have put it on there. I don't remember. Let's take a look at this problem. So I'm doing this problem tomorrow. Oh, there's FG, 100. Oh, wait, second, my bad. That's not the weight. 100 Newton force, F, is to keep an object 500. Oh, there it is. Constant velocity of 2 meters per second over a horizontal surface. Who remembers? I think we just said this. On your sheet, at constant V, what do we write? At constant V. Yeah, A equals 0, F net equals 0. So the most important thing is F applied equals friction. Write that down. So if you see that tomorrow, constant V, you say, oh, constant V, A equals 0, F net equals 0, and the most important thing is F applied equals friction. So the answer actually is 50. We didn't have to do any work at all because constant V, A equals 0, F net equals 0, F applied equals friction. Just like, remember the box we drew, and you drew a force equal, opposite? Yeah.
So if it's ever a constant velocity, it's just the same thing.
Yeah, if you're given the applied force, oh good, they just gave me the friction. Because remember the box we drew and we had the ups equal to in the test? That's why I asked you to draw it.
Did we apply force, the frictional force acting on the object?
No, the applied, no, it's not the frictional force, but remember that we did this on the test? I said, draw a box going at constant V. I very much intentionally, so once you know that it's constant V, it's not is, but it's equal to. F applied equals the frictions, just like in that, what we did in the test. So if you know the F applied, you know the friction.
But how do you know that it's asking for applied force?
Oh, it's not. It's asking for the friction. It gives you the F
Oh,
applied.
so that's
Yeah.
I thought that was a normal force.
No, this is the normal.
Wait, but then what is F of N?
That's normal.
Oh, so then why did you say that the normal force was equal to the force of gravity?
Well, that's true, but that's not this question. This question doesn't ask for normal. It asks for the friction force. And because I had the applied force, the 50 newtons, and they said it's a constant V, I got my answer.
The
No work.
horizontal force just like the applied.
Yeah. Okay, good. Up to 20 Newton block slides across, there it again, the horizontal table. This is FG, so I don't have to multiply by 9.8. It takes a 5 Newton force, oh, there it is. To move the block, there is again a constant velocity. What is the force of kinetic friction? Isn't this kind of the same question? Constant velocity. They give me an applied force. Got the answer. Constant velocity, applied force. The applied equals the friction. A equals 0, F net equals 0. And the answer is, okay. Okay, it says 4 or 10 questions. What? That's not right. A 20 Newton block slides over a horizontal table. If it takes, well, is that exactly what we did? Yeah, that's the exact question.
But 5 is what
Oh,
it says what is the coefficient?
oh, I'm sorry. Thank you. Yeah, thank you. Who said that? What's the coefficient? I didn't read very well, did I? Okay, ready? That's the coefficient is the mu. So the friction equals mu times normal. It's a horizontal table. Bridget, here's what you come in. Horizontal table, oh, the normal equals the normal equals the weight. So the mu is unknown. The weight is 20 newtons. And what's the friction? Well, that's 5 newtons because we found it out from before. What do you do to both sides? You divide by 20 because you want to get u alone. 5 divided by 20, that's 1 over 4. Right? 1 over 4, so that's 0.25. Can I X this out yet? Not yet. Go ahead. So I'll break it all down again for you. Oh, because if I want to find the coefficient, I pull out the equation. Oh, I need the normal force and the friction to get the coefficient. The friction I got because of what we said before, constant velocity. The horizontal table, the 20 newtons, that is the normal. And now I can solve. Look, I have an equation to solve for mu. I divide both sides by 20. 1 divided by 20 is 1 over 4, and that's 0.25. You got it right. Okay? We'll do, yeah.
Wait, so is that like you sub in like the FG?
Yeah. The horizontal table, normal, just like the test we did, normal equals friction. Let's see, normal equals weight. So that is friction quiz 1, I think. And let's do friction quiz 2. WD. Was so which this is the quiz you took, right? Is this worth going over, or would you? Did I not release that yet? I didn't release those? Let me release them. I thought I did.
I think you did.
Yeah, I think I did. Maybe I released in one section? Yeah, I released it on December 13th. Yeah. It's closed now. What would you like to go next now that we've done friction? Because
Wait, can you just answer this one question on what you did?
yeah.
It's on friction too. But it's also.
Okay, 1, 2, 3. Physics. Okay. And remember, those of you who came in late, the questions on 1, 2, 3 physics actually all year are tougher than the typical question I do. It's not like I would never give something that tough, but most of them are tougher than I would give. So pick a topic, mechanics, and then friction. Friction,
It's the yeah,
plugins.
it's the second one.
Yeah, that's not crazy. It's hard, but it's not crazy. Ready? So maybe make it bigger because everybody see. We did something like this in the, ready? It goes. So 30 Newton force. But I didn't really see my, I'd have to go with here. So a 30 Newton force required to accelerate. There's M, there's F, and there's A. So right away, when you just hear M, F, M, and A, that takes you back to the old stuff, right? What is the friction force? Now, you might say, no, I should use this. Someone say, well, why don't I use this? Well, how would you use it? How could you find the mu when you don't know what surface is? So I realized I can't do it this way, but I could do it like this. Let's draw a picture. Always when you have a tough time, draw a picture. So a 30 Newton force. The acceleration is 10 meters per second squared. Put this on your sheet. Over a level floor, the frictional force. Now, you know friction would go this way, right? It would be littler. So ready? F net equals MA. Why? Because I have FM and A. What goes with FM and A? So F net equals M. So the M is 2 kg. So sometimes you could do, it's very rare, but sometimes you could do a friction problem with F net equals MA. Wait a second, that's 20 newtons, but that's not the answer, girls. It's 10 newtons. Why? Because 30 minus the friction of 10 gives you 20. That's a little bit of a tough problem. When do I know to use it? When they give me F and M and A. Whatever have F and M and A, I know it's Newton's second law. I have to find the F net first, 20, and 30 minus 10 gives you 20. So that wasn't an example of a crazy hard, but there are plenty of crazy hard problems if you get. Oh, they're not? Oh, well, horizontally, this way they're equal, but this way, how could they not be equal if it's accelerating, see? If they're equal, then there is no acceleration. It must be unequal, that's why they're accelerating. Yeah. The equations for?
I get confused between the colors.
Okay, so with momentum, with friction? Oh, okay. First of all, I should tell you, can I just tell you there's not a lot of friction? It's just a tiny little topic. I think we'll have 3 questions, so you don't freak out. Friction is, there are 2 kinds. It's friction is mu times normal. And there are 2 kinds. Now, on a horizontal surface, you have to know as soon as you read that, oh, that's Fg, that's newtons. Where do you get the mu? You get that from the reference table, or maybe that's what you're looking for. Maybe they give you these two things and they ask you to find mu. Or maybe they say it's rubber on wet concrete, and then you have to actually look it up and put it in. So a lot of people are worried about friction, but it's actually quite a really tiny percentage of it. And at least two of them are like super easy. Like, what's the friction? The box is going to the right, which way does friction go? To the left. Oh, there's your friction problem. I always love to do that one. I almost always put that in the test. Friction opposes motion. Yeah, it's such a time. I think probably two of the three are super easy. Maybe there's one that's actually tough. Okay, yeah.
So do you want to do like the equations for like everything?
Do you want to do momentum now? Because momentum was the biggest topic. So momentum is, so let's go do momentum. Let's go to show me the physics. Because there are a lot of questions, so typical to the test on show me the physics. So let's go back. Since we might lose some people, let's do some tougher ones first. So let's go back to show me the physics, go to review, go to momentum, friction, and gravity. And, well, maybe we should, there was definitely some easy ones. Let's start with some easy ones because there's quite a few easy ones on momentum as well. What is the unit for momentum? Well, P equals what times what in the reference table? M times V. So isn't it my choice 4? Yeah?
Is this like the big one?
Yeah, well, let's go over that. You talked about what equations for. That right away on my test, I do this. This is in the reference table already, and then I add on to it M delta V. This is called a build your own equation type of thing. So I've got the first 3, and I just add on the third, I put it right on my test on both copies, and then if I have any equation problems, I just build my own equation. Yeah.
What's the gravity?
Okay, you want to do gravity? The gravity, there's not a lot of gravity, but the Regents loves the relationship questions, so I like to do them too. What's that relationship? That's called inverse square. So R, this is what R is. Put this on your sheet. This is what R is. So I might say, what if you triple the distance? Oops, triple the distance. That's 1/9 the force. Do I have to memorize that? No, look, up and down, inverse, squared, inverse square. Triple gives you 1/9, 4 gives you 1/16.
What do you have to use it's like M1, like now then it's equals M1.
Oh, so let's do, when we do momentum, we'll do that, all right? So check this out. Maybe I'm thinking of, did I do this one? What if you could double the mass of the Earth, double the mass of the Moon? The gravity will go up by how many times? 4 times. How about double and triple? 6 times. How about double and 4? 8 times. So you plug in the changes like they were numbers into the equation, yeah. R is the separation distance. Distance between the centers. So you want to go into the momentum stuff. Let's start doing some problems for you. Ready? Do you all see that it's mass times velocity, right? Oh, this one, I think there's a question like this. How do you do it? So simple, right? What's the greatest momentum? Do you girls remember that P equals M times V, right? So how will you do a problem like this tomorrow? So simple. 4 times 4 is 16. 9 times 3 is 27. 5 times 1 is 5. I got it. B, right? Is that easy? So I think you have a question like that. It's nice and easy. Right? Oh, this one maybe is a question. I don't know. If the speed is doubled, what other thing here will be doubled? Speed is doubled. What other thing will be doubled? Yes, Bridget? Which
I was
one?
going to say acceleration.
Not that.
That's wrong.
Ready? Watch how simple this is, girls. Watch. Yeah, watch it. You know why it is? Watch. P equals M times V. Oh, that's direct. See? Speed is like velocity. See? Isn't that nice and easy? Speed's double, momentum's double. Now, we haven't even learned, well, kinetic energy is not in this test. I hope you don't pick it because we didn't even learn kinetic energy. So don't pick that. Okay? And there's another energy, you don't pick that either. All right, let's do, you wanted some equation problems, ready? A force of 10 newtons F, this is what you do. M, T, change in momentum. I get my big equation, J equals FT from the equation sheet. Whoops, then it's delta P, and it's M delta V, and I say to myself, well, what's going to work for me? Oh, wait a second. Change in momentum's here. Oh, let's see, F, oh, F and T, look, build your own equation. Isn't that simple? Pull down what works, just build your own equation. F times T is, so it's just 10 times 8. Does it bother you that we ignore the 6? Don't worry about it. It happens. F times T, 10 times 8, 80. I got my answer. Isn't that easy? So I underline, I look at my big equation, I built my own equation. Can I X this out? Okay, let's do another one. Why is this not working? Hold on. Yeah, okay. All right, so underline 2 kilograms M. 4 meters is V. Collides, oh, this is a good one for tomorrow. Collides head on with a 1 kilogram ball going 8 meters per second south. North and south, what are you going to remember to do? What is the total momentum after? Well, it equals the total momentum before, so M1 V1 plus M2 V2. And what are you going to remember tomorrow to do, though? Is the north and the south?
Thank you.
You're welcome. You got to make the north. We got to make sure you do negative. And let's make like in math class south down, like in math class is negative. Let's make the south negative. So 2 kilograms moves at 4 meters per second, and that is north, plus 1 kilogram going 8 meters per second, but that's south, so I make it negative. And that's the hardest part, is just remembering to put the negative in there. So this is 8 plus negative 8, 0. Yeah,
And then how do you know which the equation is like M1?
great question. When do you use, because it's very important, there's about 3 or 4, write this down. When do you use M1, V1 equals M2, V2? Objects start from rest and pushed apart, or objects end at rest. Objects, most of them are going to be objects start from rest and are pushed apart. That's really most of them are going to be like, well, like a bunch that you've already seen. Objects start from rest and are pushed apart. That's when you do M1, V1 equals M2, V2. Let's see if we can find some of those. Let's go to conservation of momentum. See if we can find a problem like that. Oh, wait a second. Here it is right here. Look, look, look. 2 objects, 5 kilogram and 1 kilogram, start from rest. M1 V1 equals M2 V2. There's your answer to your question. Now, okay, the 5 kilogram moves west. Okay, 5. Now we don't have to worry about directions because they're obvious. 2 meters per second. And the 1 kilogram cart, how fast is it? M1 V1 equals M, so 10 is 1 times V. You know what's interesting? Look at these 2 choices. They're not even velocities, are they? Those 2 choices aren't velocities because they're not meters per second. So the answer is 2 meters per second. Yeah.
But why isn't it negative 2?
Well, technically, you're right. One of them is positive, one is negative, but they look at the word magnitude. When you see magnitude, that's your signal. If I get a negative value, they don't want it. Now, that's why I kind of just, you're technically right, M1, B1 is negative M2, B2. Good job. But when they said that magnitude, I thought I'd drop the negatives. They don't want that anyway. Good. There it is. Two cards resting on a surface forced apart by a spring. M1, B1 equals M2, B2. Right? Rest. Forced apart by a spring. M1, B1 equals M2, B2. The 2 kilogram goes 3 meters per second. The 3 kilogram will go, they said, what will the speed be? Oh, they don't want the direction. They said speed. So 6 is 3 times 2, isn't it? So the answer is 2 meters per second. 6 is 3 times 2. Get the picture?
Are these like the recoil problems?
Yeah,
Oh, okay.
yeah. They call them recoil. Now, this is really just the same. All this is this. Let's do something different though. Ready? Here we go. Let's try this one here. Why don't you do that one? Oh, wait a second. This is different. They collide and lock together. What do you do when they lock together? They're just one thing, right? When they lock together and join. So this is different. Ready? We'll do this problem. 4 kilograms, M, pull it 1, collides with M2. Oh, this is V1. We'll be left with 2. So they're opposite directions. They collide and lock together. So it's M1, V1 plus M2, V2. What do you do when the fact that they collide and they lock together? What goes on this side? You add them together. Because now they're not two things anymore. They're one thing with one velocity. So whenever you see collide, lock, attach, write that down. Lock, maybe you just put this equation. Collide and lock together. Collide and lock together. That's what it looks like.
So you just add them?
Yeah, they're one body now. So let's see, the 4 kilogram goes to the right, that's positive. 4 kg going to the right, that's positive. 3 meters per second. The 6 kilogram, it's going to the left, that's negative 2 meters per second, equals the 2 combined 4 and 6, that's 10 kg, times some velocity. Oh, look at this is positive 12. This is negative 12. So guess what? The total momentum before was 0, so the velocity is 0. Okay? There's another one. They're at rest, compressed spring pushes them apart. I want to find different, how about this one over here? I want to find different problems. A compressed spring is placed between two cards initially at rest. Card A is 2, card B is 1. The string that holds them together is cut. What occurs? Well, that's a good one. Read 7. Tell me what occurs. Oh, this is different, but I bet you get it. Read all the answers. Let me make this big so you can see. So this is a different kind of problem. You're welcome. Have a good day. You okay? Right? You okay with the picture and all?
Yes.
Good. So what do you say, girls? What's the answer? It's a different kind of question now, isn't it? Who knows the answer? This actually is not even the new stuff, it's the old stuff. This is the previous test. I wouldn't put this on this test because it's the old stuff. So what do they say now? What can we cross out? If we cross out anything here? I always like to cross things out when we can't get it. Cross anything out? Yeah. What do you say, Bridget? You think we can cross something like you're stretching? Can we cross it? Let me just kind of lay it out here. We've got a 1 kilogram and a 2 kilogram. Yeah. 1 kilogram and a 2 kilogram. Yeah, this is not even the new stuff. This is the old stuff. So I'm going to give you the answer. They'll exert the same force on each other, but let's see, yeah. No, the time is not the same. Time is not different. The force is not different. The acceleration of car A is, no, not, this is what, this is B. This is A, yeah. The acceleration of car A is half as much because it has twice the inertia. Don't worry about this one. That's old, this is old, this is the previous step. All right, let's, in question 7, after the string is cut and move apart, what's the same for both cars? This is a good one. But after that rest, the string is cut, what's the same for both cars, girls? Not the velocity. The momentum, because start from rest, push apart, and 1v1 equals m2v2, right? Remember that? Because I don't maybe you didn't remember the previous problem. They started from rest, string, when it's pushed apart, start from rest, push apart, m1v1, or you would say equals negative m2v2.
How do you know when to do like M1 equals M2
But wait, if they say total momentum, you add them. If they say they at rest and are pushed apart, m1v1 equals m2v2. Or if they ask you the total momentum, they start from rest, you'll know that the total momentum before and after equals 0. So you wouldn't have to do any calculations at all if they started from rest, because the total momentum.
Maybe don't we all start for us?
No, some of them have the mass and velocity. They had the collision problem. Neither of them at rest, one's positive and one's negative.
But I thought like the order for me of report comments.
Oh, those, yeah, I think they are all moving problems. Sorry.
Oh.
Just misunderstood your question. So if it's a recall problem, it's sorry.
And then when we do the momentum problems, that's like the J,
Yeah, if they talk about forces, times, masses, change velocities, if that impulse comes in, you underline and see what it is. That's an interesting question. Yeah.
I just keep
Which is what? Oh, want me to go to 1, 2, 3 physics?
Yeah, I did a problem.
Tell me what you think. Did I go to 1, 2, 3 physics? But just keep remembering, girls, some of these are pretty seriously tough problems. So I don't want you to panic tonight if you can't do a bunch of them. Because a lot of them are super tough, and maybe like 1 of 3 of those tough problems will appear of the whole test. So what's the topic? Yeah, those are super tough, the gravity plugins. They will not be relationships, not plugins, all right? So thank you for bringing it up. Forget gravity plugins. I have no gravity plugins. Yeah, they're pretty crazy. They're just putting numbers into a very complex equation. So you could just stick to gravity relationships because the weakness loves them so much. Not that they don't put plugins, but it's really very rare. And yeah.
What about gravity knowledge?
Let's take a look at gravity knowledge. Well, okay, yeah, you got to know the gravity, and I think you know it's always attractive. You do know that, right? There's always attraction. I like 2 as well. What's the gravity? Well, the force is going to be pulling in, right? Gravity is attractive, so it'd be 4. This one over here, I like it too. Look at choice B. It's an attractive force. They're equal but opposite. You know, gravity's attractive force. And don't worry about 4 because that's a plug-in. And gravity's a force that has a direction. These are good questions except for 4. 6 is, yeah, forget that. The Regents asked that one of every 7 years less is a plug-in, it's super rare. So I was focused on what you're more likely to see. Now, 6 is good. As the mass of a body increases, did you get that one? It's going to increase, right? Yeah, because gravity gets stronger with mass. So those are good problems, except for 4. So it's probably giving you a hard time. It's probably not going to be able to like test. Certainly not a lot of. Yeah, so be careful with 1, 2, 3 physics. They're really good, but be careful. Don't get yourself into a panic over some of these questions.
Do we have to know like the
All you should know, and it's not on this test, is that the weighted apples found. Remember that? The weighted apples found, which we say is 10, 0, which is all right. That's all. That is super uncommon. It happens is super uncommon as well.
For the graphs, which we know.
Yeah, the graphs for sure. Well, get through.
Yeah, I
that's
know.
sure. I get rid of that, and that's why I do it. And that's very much tested in my language question. So I do that. That's what it's the one right. So I'm going to do a Google Meet tonight from 7:30 to 8. If you still have some tough questions, I'm going to send out a link at 7:15. We'll see if we can iron out some of the issues you have. Do we cover all the topics?
For the short answer, like the ones at the end, should we just know like how to put the equations?
Yeah, you're gonna have to build your own, pull out what you need, write the big one equation, look at what they're giving me and asking for, and pull out what you need to create your own equation. Those are fairly simple as well. Yeah.
Could we just go over a gravity problem?
What kind of gravity questions? Sure.
Yeah, like.
I really like the relationships. I told you. Want to do the relationships? They're really good. So definitely the Regents likes them. I like them as well. Satellite is a distance r from the center of the Earth. Of course, the gravity is F. What if you triple the r? And so what do? Is I think, okay, I know gravity. Gravity is G m1 m2 over r squared. Oh, that's an inverse top and bottom inverse square relationship. So when you triple the thing on the bottom, triple gets squared, and it's inverse. So what is a very typical question I often put on the text? F over 9, you get that? See, it comes from the equation inverse square. Triple the r, 1/9, invert and square. Or if I said just 4, it'd be 1/16, 5 would be 1/25.
Would there be one where like you do something to the mass and the?
I don't know if I did it, but all you do is like maybe if you double the mass, triple this mass, and like double the distance. That I don't remember this. So it's 4 over 4, and it's the same. It doesn't change. So substitute the changes if they were numbers in the equation, and just ignore everything else. Just substitute. I don't remember if I did that. I don't think I did. So what is the distance? Ignore number 2. Okay, that's a pretty crazy question. Number 2. 3 you saw already. Do you remember that? The attraction of B. So how many times now? B is further away, so it's less, isn't it? So I can right away, since B is further away, it's less. I can right away just get rid of this. It's twice the distance, 1/4 as great. Just like before. Twice the distance, 1/4 the gravity. Okay?
So you just square it and then like flip it
In,
under
flip
one.
it in, yeah, invert because it F and R, up and down, invert. Yeah, here's another nice one for, so these relationships are the plugins, not stay with the plugins. So that's it, girls. I'll send you a link at 7:15ish. And so look through your stuff, and maybe something will come up, and maybe I'll be able to say, don't worry about it, or explain it. That's the homework zone, girls. Back there, you AP those. Is it killing you? If you're doing the homework, you just do it out. You do it, take one. All right. What you doing? What we doing over there, Miss Kelly? How's that looking for you? You doing all the DXs over the Ts and the DY?
Yeah.
You didn't have the data? Oh, boy. Good, good, good. And how about, oh, so you're working on the lab that's due, right?
Yeah, I did that.
And did you get that into me? This one, I don't know, just so many.
The last one?
This one over here, you said you need a lot of time. Let's see, you got it in. You crossed that.